Hey everyone, Mr. Newman here, and today what I'm going to do is I'm going to show you guys how to study for your test. And all I did was took one problem and I tried to tackle it from every angle that we've learned for this unit, so that way you guys kind of have a holistic picture of what could be on the test, all from a single problem. So let's get started. First of all, Mr. Jones gives his daughter Judy two choices of payment. She could use choice A or choice B. Choice A is earning $2 per bag raked, and choice B is shown in this table here, and we'll look more closely at that in a moment. First of all, we want to answer the question, is choice B a function? One thing, and I went ahead and answered that for you. One thing you want to do is, I want you to pause this video and see how many of these you can answer without listening to me explain it. This is going to be the best way for you to study, and then you can watch the video to see, did you get it correct? So go ahead and try all of these problems, and if you get stuck somewhere, watch the video up until that point and see if a previous problem gives you a hint for a later problem. Alright, thank you for pausing. Now that you've watched all of them, let's get through these. Yes, this is a function because each input has at most one output. Another way of thinking of that is, if you graph it, it passes the vertical line test. That means that when you draw a vertical line, it never hits more than one point. So it passes the vertical line test and it is a function. You're always welcome to graph any table or any equation that you're not sure of, whether or not, or even a mapping diagram, if you're not sure, it will pass the vertical line test. Some students much prefer to memorize whether it's a function that way. So let's see here. For choice A, the independent variable and the dependent variable, we need to figure out a sentence that uses the word depends. Some people struggle with that, and so I want to show you another little trick. You guys see how it says dollars per bag? That per, right there in the middle, is a good indicator that there is a rate of change going on there, a unit rate. And the little trick is, if you have something per something else, you always have, or you almost always have, the dependent variable per the independent variable. So let's step back and look at this. Let's look at this and write the sentence with the word depends. So I know that the money she makes depends on how many bags she collects. That means that the money she makes is the dependent variable because it depends, and how many bags she collects is the independent variable. So bags raked in is independent and money made is dependent variable. That means that money made is the y value and the bags raked is the x value. So let's make a table for choice A, and where you just filled out those headers, you should fill them all out with the independent and dependent variable like that. And so for 0, if she rakes in 0 bags, she makes $0. If she rakes in 1 bag, because it says $2 per bag, she makes $2. 2 bags would give us 2 times 2, or $4. And 3 bags would give us 3 times 2, or $6. So, what kind of functions are these? Choice A can be modeled by, well, we have 3 options. We have linear, quadratic, and exponential. One way to do this is to graph them and to look at the shape of the graph, though we have 2 tables right here in front of us, so I'm going to show you guys how to do this using a table. Lines always have a constant rate of change. That means if you figure out the rate of change from one point to another point, it will always be the same regardless of which 2 points you pick. A quadratic, on the other hand, has a constant second order difference. That means the rate of change is changing, but it's changing by the same amount each time. And the best thing to do, if you forgot that, go back and look at your notes on that one. While an exponential has a constant ratio, and remember, ratio means what you're multiplying by. You're multiplying by the same thing each time. So let's figure out the rate of change here. You notice the y, the money made, goes up by 2 each time, and the x goes up by 1. That is constant, so I know that this is a linear function. Meanwhile, looking at the other choice B, if the number of bags goes up by 1, I noticed that the money earned always doubles. So you go up by 1 there, the amount of money doubles, times 2 times 2 times 2. That happens all the way down, with the plus 1s going all the way down on the left. Therefore, this is an exponential function. I know that because it has a constant ratio, because you're multiplying by the same thing each time, not adding by the same thing each time. All right, for the next problem, I do need to fill out this table again, so let me fill that out real quick. I want to write an equation for choice A, and I'm going to use my table and the fact that I showed my work on the table as a helpful indicator. So you guys notice how there's 1 times 2 equals 2, 2 times 2 equals 4, and 3 times 2 equals 6. That means if I have X bags raked, X times 2 is how much money they'll make, Judy will make. So f of x is equal to 2 times x. Another way to think of that is if you make $2 for each bag, it's $2 times the number of bags. And x, since that's the independent variable, is the number of bags. So 2 times x is how much money f of x Judy will make. For the back, I left choice A and choice B. I just copied that on the back so you wouldn't have to flip back and forth over and over. So number 6 is continuing with the same situation. We ask, what is a reasonable domain for choice B, and what does the domain represent? We haven't talked a lot about what the domain represents, so this is good to pay attention to this and part of this problem. First of all, the domain is right there for choice B. Okay. Now I didn't include 0 here, but you could imagine if we raked 0 bags, we would make 0 money. So I would say that is perfectly fine to include that in the domain. One way to say this is all the whole numbers. Okay. Those are the numbers starting at 0, 0, 1, 2, 3, 4, and so on. And that's because you can't have negative bags raked, and she can't get credit for half a bag, or fractions of bags, or decimals of bags. It has to be a whole number of bags for her father to pay her. Now, what in the world does it mean the domain represent? Well, the domain represents all the possible inputs. In this case, it's the possible number of bags that Judy could rake. She could rake 0 bags, she could rake 1 bag, she could rake 2 bags, she could rake 3 bags. That's what the domain represents in this situation. For the next problem, I ask what is a reasonable range and what does the range represent? So again, we want to think about what does that represent. And this time it's for choice A. So $2 per bags raked. If you want to go back and look on the other side, on the right side of the table we filled out, the options were all the even numbers, greater than or equal to 0. In other words, we could have 0. If she raked 0 bags, she'd make $0. If she raked 1 bag, she'd make $2 with choice A. 2 bags, she'd make $4. 3 bags, she'd make $6, and so on and so forth. So all the even numbers starting at 0 and going up, so all of the positive ones and including 0, then that is the range. Now the range represents what kind of money she could get paid, right? What she could possibly be paid when going with choice A. She can't be paid $1 because it said $2 per bag. So she could be paid 0, she could be paid 2, 4, 6, 8, any even number until I guess she runs out of leaves. Now, for this last one, or the second to last one, if Judy rakes enough leaves to fill 5 bags of leaves, should she opt for payment choice A or choice B? What I'm going to do is I'm going to show my work by showing you how much money she makes in both. For option A, she would make $10 because 5 times 2 is 10. 5 bags times $2 each makes for $10. For option B, we see that right there on the table, so I'm going to circle that and notice that she only makes 80 cents for option B. So if she's just going to rake 5 bags, she should go with option A because she makes a lot more money that way. This last problem, though, we have to figure out how many bags she can rake. So I'm going to do this. It says Judy has 2 hours to rake the yard before going to soccer practice. I'm going to do this graphically and draw a little picture of how much time she has left. She says she can fill 3 bags in half an hour. So which payment is best? Well, here are my 2 hours. Okay, 1 hour there and 1 hour there. That's 2 hours before going to soccer practice. And she says she can fill 3 bags every half hour. So there, that little blue line, she filled 3 bags there. That half hour, she filled 3 bags there. That half 3 bags, and that half 3 bags. And so that's a total of 12 bags. I could have said, hey, let's do 3 divided by half times 2. That would get 12 as well, but I prefer my graphical method, drawing a picture of the situation and being able to understand it that way a little better. So whichever floats your boat, you may do that. But so we have 12 bags we've got to figure out for 12 bags now. For option A, We know that they're $2 each, so those 12 bags become $24. Pretty good. Option B, we don't have those numbers on the table. However, I'm going to put the table up here. We can figure out what 12 would be because we know that we just double it each time. So let's double 320, we get 640. Let's double that, double that, double that, and double that. And I don't know if you guys remember, but we talked about exponential functions very briefly. We're going to get to this more later in the year. Exponential functions grow really big, really fast. So at 12 bags, she'd make over $102, $102.40 to be exact, if she went with option B. So I know what I would choose, option B, because she makes a lot more money. Now, I said here, justify your response. Here's the justification. I filled out the rest of the table, I explained where I got the 12 from, and I even did my math here. That is how you can justify choosing option B. Thank you guys for watching, and we'll see you in class.